today is another segment, another episode of GNS 121, that is philosophy of science. And today we just want to study and do some kind of calculations, and so that for people who are not in the science department, we want to do some calculations. We want to break them down for us. And today we want to the calculation is going to focus on the physics aspect, that is the energy itself. Now let me recap from our last episode. We said energy is the ability to do work. Yes. And when we talked about the forms and the types of energy, we can have energy in various kind of forms. We can have the chemical, we can have the nuclear energy, we can have the electrical energy, the mechanical energy, and the solar energy. And don't forget that the solar energy is the one that is actually, it is the source of all energy. That is the sun. It is the source of all energy. But we have two types of energy. We have two types of energy, which is the first one is the potential energy. I'm sorry, it's GNS 121. We have potential energy and the kinetic energy. The kinetic energy. We want to do some calculations because we found out that some of us were not able to flow along in the last episode. So the potential energy and the kinetic energy. Now, what is the potential energy? I told us last time that it is what? It is the energy at rest. The energy that you are using when you are sitting down is the potential energy. The energy that you are using when you raise something up in a spot, it is the what? Is the potential energy. So the energy at rest, the energy that you are using when you are sitting down, it is what? When you are writing, it is the potential energy. Now, whereas the kinetic energy is the energy in motion. By the time you are walking up and down, you are running, you are doing something, you are exercising yourself, you are doing what? Kinetic energy. You are making use of your kinetic energy. And I told us that the potential energy, the formula for calculating is what? Is m times, okay, let me put it like this, is mass times acceleration times height. And this can be breaking down to what? M times g. This acceleration is due to gravity. M times g times h. And that's where we have m, g, h. I hope you understand like this. The m is the mass, the g is the acceleration due to gravity, the h is the height. And that's that for potential energy. We're talking about kinetic energy now. I said it is the energy in motion. Now let me just cite this. Now, the reason why you will know that potential energy is the energy at rest is that in this formula, there is nothing like as if you are moving. There is no speed. There is no velocity. Nothing like that. Mass is not a measure of speed. Acceleration due to gravity is not a measure of speed. Height is not a measure of speed. But in kinetic energy, we have what? 1/2 times mass times velocity squared. So velocity is there. It's telling us that what? It is what? Energy in motion. That's why we have what? 1/2 mv squared. I hope we've gotten that. 1/2 mv squared. Now we'll take some calculations on this now. And before we take that calculation, there is a law that is guiding energy. There is a law that is guiding energy, which is stated as the law of conservation of energy. Law of conservation of energy. I will state it now. The law states that what? Energy can neither be created nor destroyed, but can be in one form or another. Let me quickly write them out. Energy can neither be created That is, you cannot create energy and you cannot destroy it. But can change to one form or another. Which law is this? That is what? The law of conservation of energy. So that is the law. So in some questions they just tell you that energy can be dash. A, created. B, destroyed. C, changed to one form or another. D, option C. So you know that option C is what? Is the correct one. That is, it can change in one form to another. Energy cannot be created. You cannot create energy and you cannot destroy it. That is that. So let's quickly take some simple calculations. The first question is number 1. A hammer whose weight is 2 kg is raised up to height of 0.4 meter. Now, what is the potential energy? Now, without telling you that it is what is the potential energy, your instinct should tell you that what we have to calculate potential energy here, because we are talking about mass and height. And in the question, you are also given G equals what? 9.98 meter per second square. So you have been given what? G, you have been given what? Height, and you are given mass. So you should know that we have to calculate potential energy. Now, what's the formula of potential energy? Potential energy is P equals mgh. What is our M? That is mass. And mass is measured in kg. So we have to. What is our G? G is what? 0.4. And what is our G is what? Is 9.98. Yeah, 9.98. And our H is what? 0.4. Now when you calculate this very well, you will get what? 7.84 joules. Don't forget, the unit of energy is what? Is joules. 7.84 energy, joules. So let's take another question. So we're fast with our time. Another question. And we'll be more technical now. So follow very well. Now, the question says, what is the kinetic energy of a 1,500 kg car? That is, the car weighs what? 1,005 kg. The car is going at a speed of 14 meter per second. When you see meter per second, it's talking about velocity. When you see meter per second square, it's talking about acceleration due to gravity. Do we get? Now, to solve this out, they said we should find what? Kinetic energy. What is kinetic energy? The formula for calculating kinetic energy. K equals 1/2 times mv squared. Now let's begin to input our subject. The first one is 1/2 times, what is our m? 1,005. What is our v? That's 14 square. Now let's solve it down. 1/2 times 1,005. What is 14 square? 14 square is 196. 1/2. When you do 1,005 times 196, you will get 294,000. So this over 2 year 1, you say 2 year 1, 2 year 4, 7. So your answer will be 147,000 joules. That's the answer. 147,000 joules. So you're told to find what kinetic energy, half mv square, input your what? Your mass, and input your what? Your velocity. Then when you solve it down, you will get this. I hope you are clear. Let's take one or two more questions. One or two more questions. Now, in the last question that we did let us just increase the speed. Let us just increase the speed. You know, we were given 14 meter per second in the last question that we just solved. Now, let's just increase the speed to 28 meter per second. That is, we have the mass of the car to still be 1005 kg. And we want to increase the speed to what? That is V, to be what? 28 meter per second. Now, let's find Ke. Let's find Ke. So Ke equals 1 over 2 times mv squared. Now let's input our what? What is our m? 1005. What is our v? 28 squared. Let's solve down. 1 over 2 times 1, 5. 28 squared, that's 784. 1 over 2 times. When you do 1, 5 times 784, you will get 1,176,000. So divided by 2, you will get what? 588,000 joules. You get 588,000 joules. That is to say, highway speed is what? Is dangerous. Highway speed is dangerous, especially for cars that has a big mass. That has big mass. You know, the higher the velocity, the higher the energy. That's another one again. The higher the velocity, if you increase this velocity again, you will get what? A higher what? Energy that will be generated. So highway speed is what? Is not good. Let's take the last question. The last question. Now, a 1 kg meteorite. A 1 kg meteorite strikes the moon at 11 kilometers per second. Now, how much Ke does it generate? We are still told to find what? Ke again. How much Ke does it generate? Now, the first thing that we'll first of all do is to convert. Okay, we're being given 1 kg and we're being given 11 kilometers per second. So let's solve now. Our Ke, the formula for calculating Ke, don't forget 1 over 2 times mv squared again. Now, what is our m? Our m is what? 1. Now, don't forget, I told us velocity is measured in what? Meter per second. Now, whenever you are being given something like this is measured in kilometer per second. 11 kilometers per second. So try and convert it to what? To meter per second. Now, how do we convert it to meter per second? You are being given 11 kilometers to meter. Now, all you have to do is just what? To times by 1,000. A kilo is what? Kilo is what? 1,000. And I've been given what? 2. Now, to convert it back to what? You have to what? Cross multiply. That is 11 times what? 1,000. That will give you what? 11,000 meters. So 11 kilometer is equivalent to what? 11,000 meter. I hope you've gotten that. So 11,000 meter. So that is how we convert it. So times 11,000 here. 11,000 square. Yes, you know it is V square. 11,000 square. That's 1 over 2 times. What is 11,000 square? Times 1 times 1, 2, 1, 0, 0, 0, 0, 0, 0. Let's solve further. So by the time you do this, this is 1. So you still have what? 1 over 2 times 1, 2, 1, 0, 0, 0, 0, 0, 0. Then you cross this, use this 2 to cancel this, you get your answer as what? 60, 500, 0, 0, 0. So you have what? 1, 2, 3, 1, 2, 3, 1, 2. That is 60,500,000. 60,500,000 joules. You can convert this to what? Even to this, you can convert it to kilojoule back. You just divide by 1,000. So you have what? 60,500 kilojoule. It's still correct. 60,500 kilojoules. So don't forget, the formula for potential energy is what? Is mgh. The formula for kinetic energy is half mv squared. And don't forget the law of conservation of energy, which says energy can neither be created nor destroyed, but can change in one form to another. And energy is the ability to do work. We have some forms of energy, and we have type of energy, which is the potential and the kinetic energy. I know we've gained a lot today, and just kindly like and subscribe to this channel. And we've come to the end of today's episode. Kindly like and subscribe to the to this channel, and try and share to your friends. I hope you are blessed. Thank you very much.